We are exploring data section 1.2, day 1. Our objectives today are to make and interpret dot plots and stem plots of quantitative data, describe the overall pattern, shape, center, and spread of a distribution, and identify major departures from the pattern, which are called outliers, and identify the shape of a distribution from a graph as roughly symmetric or as skewed. Right, dot plots. Dot plots are a merely way of just counting what's there. Okay, so let's look at an example of a dot plot. Frozen pizza. Consumer Reports magazines rated frozen pizza in their January 2011 issue. Here are the amounts of sodium in milligrams in a single serving of 16 different brands of cheese pizza. So you have 580, 740, 850, so on and so forth. Now to make a dot plot, we're going to draw a horizontal axis as we have here, and we're going to scale it from 550 to 900 by 50. So that's because our lowest was 570 and our highest was 870. And so we went a little bit outside of that to get our range here. So we place a dot at the appropriate location. So 580. You can see there's a dot about where 580 would be. 740. 850. Another 850, which means we put the dot on top of the one that's already there. Okay. 870, another 850, and so on and so forth. 670, another 670, 630, 690 over here, 780, 610, 790, 570, 700. You can't hardly see that dot, but it's there. And 640. And those are our, that's milligrams of sodium. Notice that it's labeled appropriately. Okay. And this is quantitative data. This is data we can take an average of. Okay. Now, if we want to look at the distribution of quantitative variable, okay, we look at three main things, and this is a very important thing to us here. We talk about the shape, the center, and the spread. And the shape we're talking about is it have one peak, does it have two peaks? One peak will be called unimodal, two peaks will be called bimodal. And also sometimes can be trimodal, three peaks. But we also will talk about if it's skewed or if it's symmetric. And now nothing is in statistics, we're not expecting things to be perfectly symmetric, but it should be roughly symmetric. Okay? We'll talk about that. The center, the mean. We might use the mean, we might use the median. Sometimes we even use the mode, not very often, but sometimes we might use the mode. And the spread, we have several measures of spread. Right now we're going to talk about low to high. Just the low one to the high one. For example, back here, our spread was from a low of 570 to a high of 870. Okay? And then outliers are observations that don't seem to fit the pattern very well. All right. Let's look at an example here. Now, here are the number of calories per serving for 16 brands of frozen cheese pizza, along with a dot plot of the data. So here's our dot plot. So we want to describe the shape, center, and spread of the distribution. Well, there's two peaks here at 320 and 340. Okay, there's a big giant cluster here, and it looks like it's fairly symmetric. We'll say we haven't discussed symmetric yet, but symmetric. It looks like it's pretty symmetric. 330 is right about in the middle here. And the spread, well, they value from 260 to 380. And outliers, well, the 260 is quite a ways. Our data is all bunched up here from 290 to 380. And then 260 is a little bit away, so we probably say 260 is an outlier. It's unusually small. Okay. So if we're talking more about shape, symmetric, mirror image, this is something that might be perfectly symmetric. We're not expecting perfectly symmetric. Okay. And then there is skewed. A skewed distribution has a longer tail, and in a symmetric distribution, the tails are the same length. In a skewed distribution, one tail is much longer than the other. So you can see this here, this distribution is skewed to the right because it's got a long tail on the right. And this distribution is skewed to the left. Okay? And that will become important to us because it will tell us something about the mean and the median and how we might compare things. All right. Now let's look at stem plots. You've seen stem plots. You've heard them referred to maybe as stem and leaf plots. Okay, so let's go through how we would make a stem plot. Who's taller, male or females? A sample of 14-year-olds from the United Kingdom was randomly selected using the Census at School website. Here are the heights of the students in centimeters. Okay, so here's the male's heights, and here's the female. And we create a stem plot. Now a stem plot, we use the stem is the part that's repeated over and over again. You can see in the males here we have 154, 157, 159, 151. So we have several of them, 4 numbers that all start with 150. They all start with the 1 5. So instead of writing the 1 5 4 times, we're going to write it once, 1 5, and then we write the 151 comes first. We go in order. 151. The next one would be the 154, and then the 157, and finally the 159. And we continue that way. We do the 160s. Now it's very, very important that you have a key, because 115/4 could mean several things, at least 2 things that I can think of. Does this mean it could mean 15.4, but we intend it to mean 154. 15.4 and 154 are very different, so you have to make sure you include a key so that they know what you're talking about. All right, now, when we complete our dot plot here, our stem plot of the males, we could talk about the shape. Okay, shape, the center, which looks like it'd be somewhere around 169. It might be the center, and the spread. We can also do the females. Now the females, because there were such a small range, the smallest female was 152 and the largest was 169. Whereas the boys went from 151 to 187. They had a much bigger range of values than the girls did. So what we did, would call a split stem. The stem is split here. 15, I wrote 15 twice. The first one does the ones from 0 all the way to 4. And then the other one does from 5 to 9. So I'd do 150, 151, 152, 153, 154 on the first one, and 155 to 159 on the second one. And the same thing like that. What that does is, if we didn't split the stem, it would be harder for us to tell anything at all about shape. By splitting the stem, we can see a little bit of the distribution. We see this is kind of skewed. Looks like it's skewed a little bit. Okay. But we wouldn't be able to see that very well if we only had the 2 stems, one for 15 and one for 60. Okay.